The first type of refrigeration system that we're going to take a look at is the one that is used in most households, and that is the vapor compression system. And so this would be the system that is commonly found in a refrigerator or air conditioning system that you may have within your house or apartment. And so what happens here is the refrigerant undergoes a phase change as part of the cycle. So what we'll do, we'll begin by looking at a process schematic as well as a process diagram for the vapor compression cycle. So there we can see our schematic as well as diagram for the vapor compression system. And what we have, remember when we were looking at the rank, and I always said start at a compressed liquid, so that would be state one. Well, when you're looking at a vapor refrigeration cycle, we start at the superheated line, and that is at state one, which is where we go into our compressor. So we compress up, we go to state two, superheated fluid, and then we go into the condenser. So at this point we want to be at a temperature that is higher than our surroundings. So be that the room in the case of a refrigerator or outside in the case of an air conditioning system. And we then reject heat to that surrounding environment, and that's why we want to be at a higher temperature. And through that process, we then go through a phase change operation, taking us to state three. So there we become a compressed liquid. We then go into a throttling or expansion valve, and that is basically a process whereby we reduce the pressure. We model that as being a constant enthalpy process, and we'll see that later on. That takes us to state four, and at that point we then go into whatever space we're trying to provide the cooling to, and we absorb thermal energy from that space, be it your refrigeration, so your refrigerator in your house, or the space that you want to have air conditioned. And through that process we go through a boiling process, which we refer to as being evaporation. And through that evaporation process, what happens, then we come back to state one and repeat the cycle again. So that is a refrigerator. What we're going to do now, we're going to take a look at a video, a couple of clips of an old refrigerator and a new refrigerator, and you'll see the change in design. The new refrigerator is a little more compact, but we'll begin with the old refrigerator. So let's take a look at that now. And so what we see, the compressor on the bottom, there's the hot refrigerant going up to the cooling coils, which are mounted on the back. Those are the condensers. And then there's another tube on the left. The tube on the left is going up to the evaporators. That will flow into your freezer and provide cooling for your food. The cooling coils on the back, it's basically just a copper pipe with, it's probably a steel wire that's connected to it that has fins for heat transfer. This is a modern refrigerator. Notice there are no coils on the back. Everything has been compactly placed underneath, so it's a lot cleaner. You don't get dust buildup. So there's our compressor. In the middle is a fan, which actually causes forced convection, and that comes over our cooling coils, our condenser. And you see the condenser is neatly compacted in the bottom of the unit, no longer on the back. And then you can see the line coming out of the compressor just like we had before. So those are two different refrigerators, an old refrigerator and a new refrigerator. They basically do the same thing, except the new design is a little more compact and cleaner. So the last thing that I want to mention about the vapor compression systems is that when we're looking at a real one, in an actual cycle, we will deviate a little bit from what we've looked at, and that was kind of an ideal representation of the vapor compression refrigeration cycle. So those are the differences that we would find in a real world system. Let's write out our TS diagram again, and we'll look at those points. So we start at saturated vapor line, that's state 1, go into the compressor. Then we come back to the liquid region, go into the throttling valve, taking us to 4. So that is the representation that we have for an ideal cycle. Now in reality what we're saying is that you'll have some deviations here. One is that you're going to have pressure drops going from 2 to 3, and consequently the pressure will drop there. You'll have a drop in pressure here. And that may take us into a subcooled liquid region for state 3 and superheated for state 1. And the other thing is that when we go through the compression process itself, it may not be isentropic. And so we may increase in the entropy and go to a different state, state 2. So those are some of the deviations you may find in a real world cycle. What we'll be doing for a lot of our analysis, however, we'll be assuming it to be the ideal vapor compression system unless otherwise noted. So what we're going to do now, we're going to go on, take a look at a thing called the coefficient of performance, and then we'll work an example problem for the vapor compression cycle.